Okay, we're in the section of the appendices where it says you try. These are challenging problems. I'm not saying otherwise. Certainly there's answers down here and I'll talk you through those answers. All right, as we go through these, there's, let's see, 1, 2, 3. Oh, some pictures makes it seem longer, right? I guess there's 3 problems, right? Take a look at that. Oh, 4 problems, I'm sorry. So I'm gonna go to the whiteboard and I'll do one problem at a time. Certainly I'll read it to you and I want to encourage you to give it a try yourself. Okay, we're on the whiteboard. And I'll read it to us, find the limit. And, certainly if I were looking at that limit, I probably would have a tough time with it. I say, what do they want me to do with that? I mean, there's many ways to do it. Geez, let's take a look at that. And then what it say, it's a footnote over there. I want to claim if you read the footnote, they'll say hint. By the way, hints are only useful if you take them. Now, I'm not saying you need to take my hint, but I said they're only helpful if you take them. It says determine the area of a quadrant of the unit circle by the summation method. Well, you know what? I'll take their hint. And by taking their hint, I want to see what happens. So unit circle looks like this over here. All right. And they said the area in the first quadrant. So I'm going to shade that in for you. And that's going to be over here somewhere. And I'll shade that in. And they said I got to do this by the summation method, right? So let's write this down. And a unit circle has an equation, x squared plus y squared is equal to 1. I'm going to solve that for y. So y squared would equal 1 minus x squared. And y would equal, actually plus or minus, but since I'm in the first quadrant, it's going to be just the root. So this thing over here in this first quadrant, y would equal the square root 1 minus x squared. Let me put these points down for you. This is 0. I'm sorry, 1, 0. And this one over here, 0, 1. All right, what I'm going to do, they said summation method. Let's take a look at it. And I'll put my little triangle over there. Not triangle, a rectangle, I'm sorry. And I'm going to put this down as a summation problem. The base of that rectangle is, I'm going to divide it into n equal parts. So the area that over there is going to be approximately equal to 1 over n. And then I'll do the right endpoints. And I'm going to claim that f of x is equal to y. So f of 1 over n plus f of, I'm going to move a little bit over, 2 over n, yada, 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 until I get f to n over n. All right, let's keep writing this down. A, that's 1 over n. And this is going to be the sum. Let's see, k equals 1 to n, f of k over n. That doesn't seem too bad. Again, I'm just taking a hint. I don't know where it's going to lead. And this is 1 over n. And then what do you get over there? Let's write this down. It's going to be sum k equals 1 to n. And what's f? It's the root of 1 minus that argument squared. All right. I think I'm getting closer to it. And what I'm going to do is say the area really is a limit problem, isn't it? So the area of that quarter of a unit circle is going to be 1/4. Well, the area of a unit circle is going to be pi r squared, which is pi times 1 squared. And that's going to equal the limit as n goes to infinity of this guy over here, which is 1 over n. And it's going to be sum k equals 1 to n. We look like the original problem, see how it's written. Well, it's not written like that. So I got to write this over here. This is going to be n squared minus k squared over n squared. Again, looking back at the original problem, it's still not written in the proper form. And what I'm going to do over there, I want to point out, n is a positive integer, so I can easily take the square root of it. So the square root of n squared is just n. So a equals, this would be pi over 4, equals limit, n goes to infinity, 1 over n, sum, k equals 1 to n. And what do you get there? You get the square root on top, n squared minus k squared. And the square root of n squared on the bottom is just n. Now I can pull n out. N's a fixed number. So you get pi over 4 equals limit n goes to infinity. If I pull the n out from the summation, it's 1 over n squared, the sum, n squared minus k squared. All right, let's go back and look at that and see what they asked us. And I think I found it, and I did. And what it's going to be, it's going to be pi over 4. Let's look at the key. In the key, they put the work down, very similar to what we just spoke through. And they do say it's going to be pi over 4. All right. All right, so we did that. It wasn't too bad. I'm glad for the hint, by the way, because without the hint, problems can be really difficult. All right, let's do the next one up. The next one says find the sum of this over here. I'm gonna walk through this one over here with the blue area, so I don't have to do too much rewriting. So it wants to find the sum, and someone's going to say, you know, have we done something like this before? And we have. So you may want to look back over the notes and reread. What have we done? We've done this one over here: sine theta plus sine 2 theta. And again, we're not asking to memorize, but I hope you remember we did something like this. Whoops, sorry about that. We did something like this before. But now it's not sine, it's cosine. And what do we do before? Well, we multiply both sides by twice the sine of theta over 2. So let me outline what we're doing over here. I'll read it to you. It says, you know, we're following the same method that we did before. And what is that? We're multiplying both sides of s by theta over 2. Well, let me go through that without writing it over again. I'll write down what s is. This is s. What am I doing? I'm taking s and I'm multiplying every term on the left and right side. Yeah. There's dots here. Sorry about that. I'll put that in for you. I'll put that in later too. And let's just go over here. And so I multiply every term by 2 sine theta over 2. Now what I'm going to do is I'm going to explain we're using an identity now. I want to tell you what identity we're using, and I'll write this on the side for you. And we're using this identity over here. Whoops, didn't mean to do that. And I want to derive that identity for you. So let's put this on the side. And so I'm going to write down sine a plus b minus sine of a minus b. Now, if you remember back in Math 120, you were told that these things need to be known. They were derived for you. All the other form is derived from this over here. So let's write this down. It's going to be sine a. I'm just doing the first term. Let's see, cosine b plus sine b cosine a. I got that covered. Now let's do the next guy. And again, the next guy is this guy over here, but I have to subtract it. So I'll put that in parentheses. That's going to be sine A, cosine B, minus sine B, cosine A. And what would that give us if I did that? Well, the sine A cosine B disappears, and you're left off with 2 sine B cosine A. All right, let's go over here. I want to point out that that's written over here now. We just did that. And this would, if I were reading someone's notes, this is what I would do. I would say, gee, I don't know if that's true. I would verify it. So then what do we do? I put the dots in again. All right, dot. Okay, so I'll correct that in the notes too. Oh, I'm sorry. There's not dot there. I'm sorry. I made a mistake there. I'm daydreaming. What I'm doing. There's no dot there. Let me take a look at this and see if I did it right. I know what I did wrong over here, and I'll point out what it is. I got confused. I'm sorry. This over here is getting crossed off. And let me just see if I got that. Yeah, that gets crossed off. Sorry about that. And let me go back over here and erase. All right, I think I did that. And I'll try to remember to go back and correct my notes, by the way. Let me take a look at that. Yeah, it looks good. So the thing about this is, why would we use identity? We did something like that before. And the reason for that, what we're doing is we're taking every single term, right? What I mean by that is we're taking every single one of these terms and we're using this identity to expand it into these two things over here. And what would that be? It's going to be, looking at it, it's going to be, sine of the sum of the two angles. So I see this one over here, and then it's going to be minus the sine of the difference of those two angles. So I'm going to say over here, we get a pattern of each term. So this is first term, second term, third term, fourth term, up to that term up there. Now, if I were looking at those, it says, why did you put them on top of one another? I just couldn't fit it on one line. So I had to put it on top of one another. So then the question comes is, do they cancel? And I'm looking at it. And what I'm going to see over here is that, 2 theta minus theta over 2 is identical to 1.5 thetas, which these things would disappear, right? This would disappear. This would disappear. And by the way, there's something over there that make that disappear. Now, what disappears over here? This one, something disappears over there. So what would you be left off with looking at that? And I'll write it on the side for you. What you'd be left off with is 2 sine theta over 2. This is the left side times s would be equal to, well, I'm looking at it, it would be equal to sine n theta plus theta over 2 minus sine theta minus theta over 2. All right, let's check, see if they wrote that down. And I'm seeing that right here, right? The next thing they did, again, you might be confused by it, is it looked like they took the n theta plus theta over 2, and they simplified it. Common denominator, that would be 2n theta plus theta. Then it looks like they factored the theta out. What would they get? 2n plus 1 over 2. I'm seeing that right over there. The other thing they did was the other argument, which was theta minus theta over 2, which is fairly easy to get theta over 2. All right. So let's go to the next page and see what they wrote down next. And what they did was they said they solved now. Now, what does that mean? They solved for s. So if s is equal to, let's write this down, sine, I'm sorry. I get it in my eraser. Sorry about that. So s would be equal to sine 2n plus 1 over 2 theta divided by 2 sine theta over 2 minus, well, if you divided sine theta over 2 by 2 sine theta over 2, you get minus 1/2. So I think I got my result. And what's the result? It's right over here. All right, next up, a little more difficult, number 3. What do they want me to do? Find the volume. Well, it's for like an old problem that we've done. And, they got a picture over here. They're not asking me to, they do have a picture. I guess I could use that picture, but I'm pretty experienced. This is going to be 0 to pi. I'm kind of reading. It's a volume problem, right? And that's an integration. I'm sorry, I got summations on my mind. So the integration is going to go from 0 to pi. And then what are you going to get? You're going to get pi. And what's the radius squared in that? It's going to be the sine function squared. And then dx. All right, this is, looking at it, I'm not saying it's a difficult integration, but you may forget. But that is the volume, all right? That's the volume. Now, what am I doing over here? A little tough time with it, but let's write this down. I'm going to pull out a pi. You should probably use the double angle formulas, and the sine squared is going to be 1 minus cosine 2x over 2 dx. Looks like a relatively simple question now. What do you get? Pi. I can integrate this guy now. It's going to be 1/2 x. And what do you get there? Minus, that will be sine 2x over 4 now. Integration 0 to pi. What's the volume? Pi. This should be 1/2 of pi. Well, sine of 2 pi is 0, so I'll put that down. And then, last but not least, what do you get? Minus pi, and that would be 0. So that looks pretty simple. And what do you get over there? Well, the volume would be pi squared over 2. Let's check. And we did it. We got it. All right, number 4, I'll be honest with you. This is super tricky. These are the kind of questions that a lot of students would have experience with. But on a competitive exam, this would kind of like, I'd say that for the most part, if you weren't familiar with it, you'd probably get stuck doing this. So I want to point out, it wants you to verify the above result using summation notation, right? This will be tough, right? So what I did was, I'm not going to say it's easy, but what I did was I divided it into two parts, all right? So the first part I divided into, and I'll put this down for you. Let me get a highlighter out. This is the first part, right? I hope that's pretty easy to understand. I just did this part over here. And then I said, oh, this is the second part. And someone says, why would you do that? Because I really realized that if I wrote down a sum formula for the full region, I couldn't do it. I just couldn't do it. You can try though. And then what I noticed over here is that, and I'll point this out to you, this region here is identical to this region over here. They're identical, absolutely identical. But what is this region over here? It's the cosine curve. Now someone says, why are you doing the sine and cosine? You're making it more difficult. The reason is we're squaring these guys. So if we're squaring these guys, hopefully it'll become easier to do. Let's go to the very next page and I'll read it to you. I know it's difficult. I'm not saying it's going to be easy for you. Granted, this is a bit tricky. There's no doubt about it. Pictures were helpful, by the way. I'm basically dividing the region into the sine x into two parts. We just did that before. The figures are written down for it. The first one's between 0 and pi over 2. The second one's between pi over 2 and pi. And then what I do is I notice that, the sine curve between pi over 2 and pi is really identical to the cosine curve between 0 and pi over 2. Images are provided as necessary to understand the process. So what I do? Well, I did it. What I do is I divided it into two parts and I wrote a summation down like this. That's the first region, right? That's the first region. That's the sine curve, the rotation. I'm doing it by disk. And then I did the cosine curve. They have the same limits, and the limits are going to be from 0 to pi over 2. Then I wrote as a sum formula like this over here. But I put the sum, well, that internal sum is why I did that. The internal sum is super easy. It's just 1. Now what do you do? What's the sum of k equals 1 to n is n. So what do you get over here? This over here. What do you get? Pi squared over 2. Certainly tricky. All right. This takes time for students to think. You need to take the time to think through this. All right. Is it tricky? Yeah. Even with a hint, so as it's divided into two equal parts, it's still going to be tricky. They could give you a dozen hints in this problem, still going to be tricky. Here's the deal though. It becomes less tricky as you study these things. All right. So I wouldn't expect anyone to do this on their own, but you should be able to follow what I did. But it's going to require thinking. You can't just look at that and say, gee, I got that. That takes time. It took me time to get through it too, by the way. All right. So hopefully you're willing to think through that and get a result from that. And thank you for your attention. Let me call it quits on this.